The seventh question that we have is again an interesting question which appeared in JEE some time back. We have to find out which statements are correct. We have two bars of the same material. The radius of this bar is 2r and the radius of this bar is r. They both have the same length. The first part is, let us see if the option A is correct or not. Heat produced in bar 1 is 2 times the heat produced in bar 2. So let us find out the heat produced in the two bars. The first thing we know that it is also given that there is a current I flowing through it. Now the current I will be same throughout the two bars because the current does not change. Now the heat produced in bar 1 will be equal to I square, will be directly proportional to I square into the resistance of bar 1, and the heat produced in bar 2 will be equal to I square into the resistance of bar 2. The will be proportional to I square R2. Therefore, if you can find out the resistances, we can easily find out if the heat produced in bar 1 is 2 times the heat produced in bar 2. So for the bar 1, the resistance will be equal to rho into L, that is equal to L by 2, upon A, that is equal to pi into 2R whole square, that is pi into 4R square. For the second bar, it is rho into L upon 2 upon pi into R square, that is the area of cross section. Clearly we see that this is 1/4 of this quantity. Therefore the resistance of bar 2 is 4 times the resistance of bar 1. Therefore the heat produced in bar 2 will be 4 times the heat produced in bar 1. Therefore the A option is wrong. Now look at the second option. We have electric fields in both bars is equal. Now for solving this part, you should know this very important formula which students generally don't remember. This is J vector is equal to sigma into E vector. This is no special formula. This is just a derivative. This is just another form of the Ohm's law. That is V is equal to IR. You should also remember this form because in JEE particularly they have asked this several times. J is equal to C sigma into E vector, where sigma is equal to 1 upon rho. That is the density of the material. E is the electric field and J is the current density, that is equal to current upon area of cross section. So when we look at this thing over here, we have to check for the electric field. So for the electric field in both of them to be same, J vector has to be same because sigma is already same. Now for J vector, sigma is same because they are of the same material. Now for J vector to be same, J vector is current upon area of cross section. Current is already same in both of them. So the area of cross section has to be same in both of them for electric field to be same. Now we see clearly that the area of cross section is different. Therefore electric field in both of them will be different. Therefore B option is wrong. Now for the C part, current density across AB is double that of across BC. So current density is I upon A. So for current density across AB to be double of that across BC, the area of cross section should be half of that of bar 2, which is clearly not there. Therefore C option is also wrong. Now the D part is, now since these three are wrong, therefore D has to be right. But still let us check it. Potential difference across BC is 4 times that across AB. So let us find out the potential difference across AB and across BC. The potential difference across AB will be equal to I into R, where R is the resistance, that is equal to I into rho L upon 2 upon pi into 4R square. For this the potential difference will be equal to I into rho L upon 2 upon pi R square. So clearly we see that the potential difference across BC is 4 times the potential difference across AB. So our D option is correct and thus we get the final answer. So what we learned from this question was that you should also remember formula, you should remember J vector is equal to sigma into E vector, and this formula can be applied in many places to solve many other questions also. So this is an important formula that we learnt.